In the figure, line AB is parallel to line CD and line PQ is the transversal. Ray PT and ray QT are bisectors of angle BPQ and angle PQD respectively. We have to prove that measure of angle PTQ is equal to 90 degrees. Now look at the figure. You can see ray PT bisecting angle BPQ because it is given ray PT bisects angle BPQ. So you can write angle BPT is congruent to angle TPQ. When the angles are congruent, the measures are equal. Angle BPT is measure of angle BPT is equal to measure of angle TPQ. Let us take the measure to be x degrees. So look at the figure. Look at the second figure. We have marked measure of angle BPT to be equal to measure of angle TPQ to be equal to x degrees. Let us take measure of angle BPT and measure of angle TPQ, which are already equal, to be equal to x degrees. Take this as equation number 1. Now, angle PQT is congruent to angle TQD since ray QT bisects angle PQD. It is given in the question. Ray QT bisects angle PQD. So, measure of angle PQT will be equal to measure of angle TQD. Because the angles are congruent, the measures are equal. Let us take that equal measure to be y degrees. So let measure of angle PQT equal to measure of angle TQD is equal to y degrees. Take it as equation number 2. Now look at the figure. Measure of angle PQT is equal to measure of angle TQD is equal to y degrees. I marked this in the second figure. Look at the figure. Now we have from the first equation measure of angle BPT is equal to measure of angle TPQ is equal to x degrees. And from the second equation we get measure of angle PQT is equal to measure of angle TQD is equal to y degrees. Now, line AB is parallel to line CD is given in the question and also line PQ is the transversal is given. Now look at the interior angles. Look at line AB, line CD which are parallel and line PQ is the transversal. So the interior one of the pairs will be angle BPQ and angle PQD. You know the property of interior angles. Sum of the measures of the interior angles will be equal to 180 degrees. You know that interior angles are supplementary. When the lines are parallel, you get interior angles to be supplementary by interior angles theorem. Here angle BPQ and angle PQD are interior angles. So you can write measure of angle BPQ plus measure of angle PQD is equal to 180 degrees. Write the reason. Now coming to the next step. Measure of angle BPQ. This can be split up as measure of angle BPT plus measure of angle TPQ. Look at the figure. Look at angle BPQ first. Then look at angles BPT and angle TPQ. Now you can write measure of angle BPQ as measure of angle BPT plus measure of angle TPQ. Similarly, you can write measure of angle PQD as measure of angle PQT plus measure of angle TQD. This is because of angle addition property. Now you can replace because of equations 1 and 2. You can replace all these angles by x degrees and y degrees. Now see, measure of angle BPT is equal to measure of angle TPQ is equal to x degrees in equation 1. So substitute those measures here. Now here, so it becomes x plus y is equal to 180 degrees. Otherwise, x degrees plus y degrees is equal to 180 degrees. Now, x plus x is 2x. Y plus y is 2y. So you get 2x plus 2y is equal to 180 degrees. Take 2 common outside. When 2 is put outside the bracket, inside the bracket you will get x plus y. 2 is common outside the bracket. So inside the bracket you will get x plus y. Keep x plus y this side. Take 2 to the other side. 2 multiplied by x plus y. So when you bring 2 to the other side of the equal to sign, it becomes divided by 2. X plus y is equal to 180 degrees divided by 2, that is equal to 90 degrees. Take it to be equation number 3. Now, in triangle PTQ, you get sum of the measures of all angles of the triangle is 180 degrees. Therefore, measure of angle PTQ plus measure of angle TPQ plus measure of angle TQP is equal to 180 degrees. Now, from equations 1 and 2, we can substitute the values of measure of angle TPQ and measure of angle TQP. So, you will get measure of angle PTQ plus x plus y is equal to 180 degrees. Now, from equation 3, what is equation 3? X plus y is equal to 90 degrees. It has to be taken as equation number 3 now. You got x plus y is equal to 90 degrees in one step. That step has to be taken as equation number 3. So from equation number 3, you get measure of angle PTQ plus 90 degrees is equal to 180 degrees. Mark this step x plus y is equal to 90 degrees as equation number 3. So now from equation number 3, you get measure of angle PTQ plus 90 degrees is equal to 180 degrees. Therefore, measure of angle PTQ is equal to 180 degrees minus 90 degrees. Taking a plus 90 degrees to the other side of the equal to sign, you will get minus 90 degrees. So, 180 degrees minus 90 degrees will become 90 degrees. Therefore, measure of angle PTQ is equal to 90 degrees. Measure of angle PTQ is equal to 90 degrees. Now coming to the 10th problem. So you are given line DE is parallel to line GF. Ray EG and ray FG are bisectors of angle DEF and angle DEM respectively. You have to prove that angle DEG is equal to half of angle EDF and EF is equal to FG. That is, measure of angle DEG is equal to half of measure of angle EDF, and also you have to prove that EF is equal to FG. Now, ray EG bisects angle DEF. Look at the figure. So, you get angle DEG is congruent to angle GEF. When the angles are congruent, the measures are equal. Let us take the equal measure to be x degrees. Take it as equation number 1. Now, consider angle DEF. It can be split as angle DEG plus angle GEF by angle addition property or postulate. Anything you can write. Now, equation 1 tells us that measure of angle DEG is equal to measure of angle GEF is equal to x degrees. So, put the values here. So, in this equation, when you put the value of measure of angle DEG and measure of angle GEF, you will get measure of angle DEF is equal to x degrees plus x degrees. That is equal to 2x degrees. You have to write the reason beside it from equation 1. X degrees plus x degrees will be 2x degrees. So you take this equation measure of angle DEF is equal to 2x degrees to be equation number 2. Now, line D is parallel to line GF. Look at the figure and the question. In the question you are being given line D is parallel to line GF and we are taking line EF to be the transversal. Now we have the corresponding angles. Angle DEF and angle GFM are corresponding angles. You can look at the figure. You can see angle DEF and angle GFM to be corresponding angles. By corresponding angles theorem, when the lines are parallel, the corresponding angles are congruent. So, angle DEF is congruent to angle GFM. You have to write the reason beside it. Corresponding angles. When the angles are congruent, their measures are equal. So, measure of angle DEF will be equal to measure of angle GFM. Now, look at equation number 2. We have measure of angle DEF to be equal to 2x degrees. So, now substitute over this equation. Measure of angle DEF is equal to 2x degrees. Therefore, GFM will be 2x degrees. You have to write the reason from equation number 2 and take this equation as equation number 3. Now let us discuss about angle DFG. You are given ray FG bisects angle DFM. So, angle DFG is congruent to angle GFM. When the angles are congruent, Their measures are equal. So measure of angle DFG is equal to measure of angle GFM. Now look at equation number 3. You are given measure of angle GFM to be 2x degrees. Now put that here. So this equation becomes measure of angle DFG is equal to 2x degrees. Within brackets you have to write the reason from equation number 3 and take this to be equation number 4. Now, what about measure of angle DFM? It can be split up as measure of angle DFG plus measure of angle GFM. This angle can be split up. Angle DFM can be split as angle DFG and angle GFM. So, measure of angle DFM will be equal to measure of angle DFG plus measure of angle GFM by angle addition property. Now from equation 3 and 4, you get measure of angle DFG to be 2x degrees and measure of angle GFM to be 2x degrees. So measure of angle DFM will be equal to 2x degrees plus 2x degrees. Now adding that you get 4x degrees. So measure of angle DFM is equal to 4x degrees. Take this equation to be equation number 5. Now in the figure you can see angle DFM is an exterior angle of triangle DEF. First of all, look at triangle DEF. One of the exterior angles is shown here, angle DFM. Angle DFM is the exterior angle of triangle DEF. So you can use the remote interior angles theorem and write measure of angle DFM is equal to measure of angle EDF plus measure of angle DEF. Because angle EDF and angle DEF are the remote interior angles of triangle DEF when angle DFM is the exterior angle. Angle DFM is taken to be the exterior angle, so we get angle EDF and angle DEF to be the remote interior angles. According to the remote interior angles theorem, the measure of the exterior angle will be equal to the sum of the measures of the remote interior angles. Now put the values here. Measure of angle DFM is equal to 4x degrees by equation number 5. So 4x degrees is equal to measure of angle EDF plus 2x degrees because measure of angle DEF is equal to 2x degrees. We have in equation number 2. Now, therefore, measure of angle EDF will be 4x degrees minus 2x degrees. Bring plus 2x degrees to the other side, then it becomes minus 2x degrees. Now 4x degrees minus 2x degrees is 2x degrees. Now we can replace that x degrees by measure of angle DEG from equation number 1. In equation number 1 we have measure of angle DEG to be x degrees. So replace this x degrees by measure of angle DEG. Then you get measure of angle EDF is equal to 2 into measure of angle DEG. You write the reason from equation 1. Now bring 2 to the other side. So we'll get half into measure of angle EDF is equal to measure of angle DEG. So measure of angle DEG is equal to half into measure of angle EDF. So we have proved the first part. Two parts are there to be proved. Now, you have to prove now EF is equal to FG. So what you are going to do? Take line DE parallel to line GF, that is given, and line EG to be the transversal. Now look at the figure. You get angle DEG and angle FGE to be alternate angles. So you can use the alternate angles theorem. When the lines are parallel, the alternate angles formed are congruent. So now here, angle DEG and angle FGE, look at the figure, are alternate angles. So you get angle DEG is congruent to angle FGE. You are given line DE is parallel to line GF, and you have to take line EG to be the transversal. You have to look at the figure very carefully. Then you are getting the alternate angles to be angle DEG and angle FGE. Now since the lines are parallel, by alternate angles theorem, you get these two angles to be congruent. The alternate angles to be congruent. So angle DEG is congruent to angle FGE. When the angles are congruent, their measures are equal. So measure of angle DEG is equal to measure of angle FGE. Now substitute the value of angle DEG. Measure of angle DEG is equal to x degrees by equation number 1. So you get measure of angle FGE to be x degrees. Now take this equation as equation number 6. Now coming to triangle FEG, we have to ultimately prove EF is equal to FG. So you take triangle FEG. Now from equations 1 and 6 you get angle FGE to be congruent to angle GEF. Because their measures are equal, the angles are congruent. So angle FGE is congruent to angle GEF. So you can apply the converse of isosceles triangle theorem. So by the converse of isosceles triangle theorem, in a triangle when two angles are congruent, the opposite sides are congruent. Therefore EF is equal to FG. You have to write the reason by the converse of isosceles triangle theorem. Hence we have proved the second part also. Now question number 9 is very simple. You have to use only vertically opposite angles, angles in a linear pair, and sum of measures of all angles of a triangle is 180 degrees. So you can do that as homework. Page 28 in your textbook. Question number 9 in page number 28.